Hey friends, so this video is going to be on solving exponential equations. So if we look at our first example here, this is an exponential equation because this right here is an exponent. And so, by the way, is this. So because those are exponents, this is an exponential equation. First thing we want to do to be able to do an exponential equation is we have to have the base be the same. And because the bases are the same, what we can actually do with the bases is we can think of them as not being there at all. Since they are the same thing, they all strike each other out. And now you're left with the very simple problem of x plus 1 equals 9. So x equals 8. And that's the answer to the question. It's not any more difficult than that. Don't make it any more difficult than that. That's exactly what it is. So when we go to this question, the first one we want to look at are the bases. We notice that the bases are the same. If the bases are the same, they don't even need to be there. So if the bases are the same, they're not even there. So our algebra problem is 4n plus 5 is equal to n minus 7. And then, of course, we're going to solve for n by moving an n and by moving the 5. And so we have 3n is equal to negative 12. So n is equal to negative 4. The problem comes when the bases are not the same. When the bases are not the same, you need to think about how to make them the same. And so what I notice is that 36 is equal to 6 squared. So with that being the case, I can rewrite the problem as 6 to the 2x minus 10 is equal to 6 to the second power. In other words, I'm taking the number 36 and rewriting it as a base. And now that my bases are the same, and that I have a 6 here and a 6 here, I don't need them anymore. So I have the problem 2x minus 10 is equal to 2. So 2x is equal to 12. So x is equal to 6. And so if we look at this one, we notice that our bases are not the same, but the bases need to be the same. So if the bases need to be the same, then I can say that 8 is equal to 2 to the third power. So I'm going to change this equation so it looks like this. And then I'm going to, now that the bases are the same, they'll cancel each other out. We'll have p minus 7 equals 3. So p equals 10. Four is equal to 2 squared. 8 is equal to 2 to the third power. So if I take this and substitute it in for the 4, and if I take this and substitute it in for the 8, then the problem is going to say 2 squared times 3x and 2 cubed times x minus 1. So then I am going to simplify these. And these are now the same, so they're going to disappear. So I have 6x is equal to 3x minus 3. 3x is equal to negative 3. X is equal to negative 1. And then if I go here, I can think of 27 as 3 to the third power. So this is going to be 3 to the third power times 2x plus 6 and 3 to the 2x. And now my bases are the same. So I can get rid of my bases. And I'm going to have 6x plus 18 equals 2x. So I am going to have 4x equals negative 18. X is going to equal negative 9 halves, which is just fine. There's nothing wrong with that. Okay, 27. 27 is, whoa, hi, wrong. 27 is 3 to the third times 2x equals, and this is 3 to the, I think it's a 5, we'll check, times x minus 2. Let's see, 243. Three to the fifth power is 243, yep. So now what we're going to have is 6x equals 5x minus 10. So x is going to equal negative 10. Okay. 16 is a base 2 number. 16 is 2 to the fourth power. And then we still have our 3x. And 8 is 2 to the third power. And we still have our x plus 2. And now that our base numbers are the same, we're going to have 12x equals 3x plus 6, 9x equals 6, x equals 2/3. Yep, and that is it. And of course you can put them in your calculator to check them. If I check that last one, 16 to the 2/3, 16, 3 to the 2/3 equals that number, and 8 to the 2/3 plus 2, 8 to the 2/3 plus 2 should equal 256. And it does, so they equal each other, so they are the same. You can always check them on your calculator to make sure you're right. If we check this one, 27, 2 to the negative 2, negative 10. 27 raised to the 2, negative 10. And doesn't matter what it is, just leave it there. And the other one is 243, negative 10 minus 12. 243, negative 10 minus 12. 243 raised to the negative 10 minus 12. I wonder if it'll do it that way. That would be 243 raised to the negative, 243 raised to the negative 22nd. Huh. I wonder what's wrong with that one. Oh, it was 2 times negative 10, so it would have been a negative 20. It's the first one I did wrong. No, I did that one right. Three times 3 is 9. 9 times 3 is 27. 27, or 3 times 2x is 6x. And then over here we have 3 to the 5th, 5x minus 10, subtract 5, leaves you 1, minus 10, 27 to the negative 20. That one should have worked. 27 to the negative 20. And 243 to the negative 20. Huh, okay, so why didn't that work? That should have worked. So what was I checking? I was checking 27 to the negative 20 and 243 to the negative 12. Haha, I see my mistake. Should be a negative 12. Right? To the negative 12. 243 to the negative 12. Yep, that's it. It works. Perhaps if I could do the basic math. Anyway, you can plug it in if you plug it in correctly to see if it works. So it did work. My bad. All right. So that is it. I think that's the last example. Yep, that was it. Thanks, guys.